Hi guys, good afternoon. So far we have seen question 1, policy based, site to site VPN without NATP, and then same thing we have seen, which is with NATP. So these two things right now we have seen between the routers only. Now today what we'll do is we will go with question 1, site to site, which will be without NATP, okay, between ASA and router. If one side there is ASA and on the other side if there is router, then how you are going to configure the VPN. This is what we are going to see today. Okay, so let's go and create the lab. Everybody has received the access to the lab, right? You guys can start your practice. Let's do. So how your practice is going on? Able to do everything? Huh? So ASA was not required so far. With NATP also you could have used a router also. In the router also you can configure translation, right? No problem. And what about the task? Changing access list, changing key, no? Okay. So we'll go with my question 1, policy based, site to site, VPN in between ASA router. Take the notes. So we will require one ASA. This is ASA. and 3 routers. And this is site A inside R1. And this is your ISP. This is site B. And this is site A, ASA. And this time the tunnel setup will be there between ASA and site B. Okay. 0 by 0 on the inside, 0 by 1 on the outside. And this is site B. 0 by 1. Okay. Now let the devices come up. On the site A inside, we will use the network. Let's see, 10.110/24. Here we will be using, let's say, 11.110. On this side, we will be using 12.1.1. Okay, and if you want, we can use a loopback also. Ten dot two dot two dot zero slash. Okay. Now, here we will be using the IP 10.1.1. This will be 10.1.1.10. On the outside, 11.1.1.10. 1111, 11, 12, 11, 11, and this 12, 11, 10. Okay. Now let's go and do the basic configurations. First of all, site A. Okay. Inside R1. Configuration terminal. Host name. Then interface. X0/0. IP address 10.1.1. No shutdown. IP route. Then we can say gateway will be 10.1.1. Okay. Here we don't require loopback. I'm considering this as inside here. Okay. Here we don't have inside, so that's why we have taken a loopback. Okay. Then after site ASA. Host name is done. Interface X0/0. Name is and site. IP address 10.1.1.10, 255, 255, 255, zip. Then no shutdown. Then interface. This will be outside. This will be 11.1.1.10, and we configure it out. This will go for 11.1.1. This will not be configured like this. Like this. Okay. Then we have to go and configure ISP. Host name ISP. Interface X0/0. 11.1.1 down. Z0/1. This will be 12. And we don't need a route on the ISP. Site B configuration we have to do. The terminal, host name, site B, interface X0/0, IP address 12.1.1.10, no shutdown. IP address. Okay. default route towards ISP. This is our basic configuration. Okay. Now let's take access of all the devices. ASA, side B, ISP. Copy. Right. ASA. Then we have side B. Then we have ISP. Now the first thing that we are going to check here, we are going to check the connectivity. From where to where we should test? Okay. The first connectivity that we are going to test will be from here to here. Second connectivity will test from here to here. Okay. Shall we test the connectivity from here to here? No. Why? Because ISP won't have a route and the reply will be blocked. So we already know this thing. Okay. So no need to test. So these two connectivities we will test. Okay. So let's go and check. Now, first of all, from site A inside, I'll say ping 10.1.1.10. This is fine. Then ASA2, we have to check the connectivity from ASA2 12.1.1.10. Let's check. Host name has not been changed. Why? Configure terminal. Okay, it's kind of special characters we cannot give. So let's check. Thing. Connectivity is there. Okay. Now what we need to do, we need to go and configure what? Yes, VPN we need to configure, right? We will configure IPsec here. Okay. So let's go and configure first of all on the router because you already know how to configure on the router. So now tell me the commands. Crypto. First of all, ISACAM profile. Policy. Any number we can give. Then haggle we will give. So hashing will go down. We will use SHA 256. Okay. Authentication, any format you can use. Reshare. Then Duffy-Hellman group. 14. 14 here we cannot use because ASA will not support it. So let's go with 5. Okay, group 5 right now we are using here. Okay. Then encryption. We'll go with AES. Then lifetime, let's keep it default. Every time I'm configuring, this time I will not configure. It's the same thing. Okay. So this is done. Now, with crypto. Okay. E, 0. E we will configure Cisco. Then we'll give what? Address. And what is my peer address this time? 11.1.1.10. Because where we are configuring right now on the site B here. Okay. So address will be 11.1.1. Right. So phase 1 is done. Now let's go for phase 2. So we will say crypto, IP set, transform set, P set, then ESP, AES, ESP, SHA, HMAC, SHA 256, HMAC. Okay. All right. This is done. Exit from here. Now we will configure access list. So access list, unbit, omit, all the protocols, IP from the host. Where to where? This loopback to this loopback communication or this inside communication we want to secure. Okay. So from 10.2.2 to 10.1.1.1. Okay. To the host 10.1.1.1. This is done. Then crypto map, C map, give a number, and then IP set, ISACAM. Then who will be my peer? Same. Earlier, whatever the peer I gave, same will be my peer again. 11.1.1.10. Then transform set, P set, and I will match the address that is there in the access list number 1. Step number 4 is done. Last step is interface. So interface, gig 0/0, crypto map, and C. This is done. Okay. We can see on this site, ISA campus on. Now, ASA site configuration we have to do. Okay. Now, go to the global configuration mode and see here. If I use crypto, now check here. What is the option I have? See, if you give Isaac amp here, now we don't have option to create here what? Policy. So we will not configure this one right now. See here what we are configuring. So here instead of Isaac amp, we will go with the IKev1. So you will say crypto IKev1. Now you see policy option. So we will say policy and any number you can use, let's say 10. And in this one, you will configure the haggle. Okay. So again, same thing, hashing. Do we have option for SHA-256? No. So I think we might have to go and change there also. We will see. Let's configure SHA here. Authentication. So authentication pre-share option is there. Duffy-Hellman group, right? So see here, we have only option for 1, 2, 5, and 7. 7 is deprecated. So we have to use 5 only. Then encryption, we will go with the AES. Okay. Lifetime. So we can use 86400. Okay. This is clear. Okay. Now this is done. Okay. After this, what we used to configure there? We used to configure the key, and we used to use the command crypto ISAcam key, right? Here we use the keyword no crypto. Directly we use the keyword tunnel group. Okay. After the tunnel group, see, actually it is asking what? Some name of the tunnel group. But this should be the name should be your peer IP address. Now, what is my peer IP address for the ASA? 12.1.1.10. So I'll say 12.1.1.10. This thing I have given. Now see, what it is asking? Type. And right now we are using what? IPsec. Now this is a LAN to LAN VPN or remote access VPN. This is a LAN to LAN. So we will say IPsec L12. This is done. Okay. Now again use the command tunnel group 12.1.1.10. Okay. And this time you get option for what? IPsec attributes. IPsec attributes. Now we are in the IPsec attributes. Here we can configure this. Okay. So let's go and configure. So what we are configuring right now, IKev1. So I'll say IKev1. Then you will say pre-shared key. And then you can use the keyword 0 here also. And you can configure the key, which is Cisco. Done. Okay. So phase 1 configuration is done. Now for phase 2, what we used to do? Transform set. So what we will say? Crypto, IPsec, and there we used to directly say transform set. But here what we have to say? That we are applying which settings? IKev1. IKev1. Then what is asking? Transform set. Now we have to give a name. Set. Then after, whatever we are using, ESP, AES, and ESP. And again, we don't have the SHA-256 here. Okay, so on the other side, we have to change SHA attachment. This is done. Okay. Once this is done, now what was the next step? Access list. So we'll say access list. Let's configure it with the name tunnel. Okay. Then action is what? Permit. See, in ASA, there is no numbered ACL. So we will use a name here. You can use any name. Okay. So we'll say permit IP from which host? This time it will go from 10.1.1.1. Okay. So 10.1.1.1 to the host 10.2.2.2. Correct. So this is done. Wait a minute. No. We have given host access list. Okay. It's not taking. Why? Because we are in the wrong mode. So yeah, we have to go to contribute. This is the access list. Okay. After the access list, what we used to do? Crypto map. Now crypto map. Then give a name, CMap, give a number. So let's say I'll give the number again, 10 here. Okay. After this here, directly we will say everything. Okay, there in the crypto map, we used to set the peer, the transform set, address, right? Here we will say everything in single command. Like I want to set the peer. So here I'll say set peer. And what is my peer IP address this time? 12.1.1.10. There also in phase one, I mean, on the router also, we are not using the access group. This ACL here, it is being used to select the traffic, not to filter. Okay. We are just selecting interesting traffic here. Then in the same transform, I mean, in the same crypto map, set IKEv1 transform set, and transform set is set, and then in the same access list, we will say match address, and what is the access list name? Tunnel. Okay. And then we used to do what? We used to apply the crypto map on the interface. So here also you will use the same command. Okay. That crypto map, CMap, and on which interface you want to apply it? Outside. Now on the ASA, your IKEv1 is not enabled by default. You have to enable it. So how you will enable it? You will say crypto IKEv1 enable. On which interface you want to enable it? Outside. Okay. This is clear. So let me check the history. Show history. These are all the commands from here. And let's paste them. VPN configuration. First of all, on the site ASA. Okay. And this is the first configuration. This is the key configuration. Okay. And here the key we have used is Cisco. These exit commands. And then everything related to the okay. This is all the configuration we need to do. And on the router, whatever the configuration we did, that is on the side B. So this was almost same. Here we will say ISACAM. Then you will say crypto ISACAM P0 Cisco address, and peer address is here 11.1.1.10. Then after you will set what? Crypto IP set, transform set, P set. Then you say ESP, AES, ESP, SHA, attachment. Okay. Then after access list, 100 permit IP host from 10.2.2 to the host 10.1.1.1. And then after crypto map, CMap, 10 IPsec, ISACAM. Then in this you said set peer and peer IP addresses LAN11 can set transform set, set, then set match, address 100, and then we went to the interface, gig 0/0, and you set crypto map C. Okay. So right now, this tunnel might not come up because some parameters are changed. Hashing algorithm SHA-256 is there on the side B, and encryption algorithm also changed here. Okay. So let's check first of all. Okay. So on the side B, I'm going and I'm saying show crypto ASA account SA, no tunnel. Show crypto IPsec hash. So here also no inbound ESP, no outbound ESP. Okay. All right. Now let me go and capture some packets here. Some packets are coming. Now from inside, let me try to ping. If I say ping 10.2.2.2 source 10.1.1.1. Let's see whether we are able to ping or not. See, messages are there, but the tunnel will not get established. Why? Because of the parameters. Okay. So here we have to change the parameters. New parameters will be these. And also in this one also we have to change. So let me copy this much and paste again. Okay. Crypto ISA account SA. This is active and deleted. Show crypto IPsec SA. Okay. Now let's initiate the traffic. Do you see? We are able to ping. And since we are able to ping, we can see that the tunnel is established here. Okay. 6 messages for main mode, 3 messages for quick mode. Okay. And these messages, these are between the ASA and the site. Okay. So same, the packet capture will remain as it is. There will be no change because same protocol IPsec we are using. Okay. There was just a difference between how do you configure these things. Okay. So now on the ASA, how do you check the tunnel? You say show crypto. Now in the router, how do we check the phase 1? Show crypto ISACAM, but here we don't use ISACAM, we use IKev1 ASA. So see, this is the peer 12.1.1.10 and this is ASA, right? So this is the peer. Type of VPN is what? LAN to LAN. What is the role of ASA? Initiator, and this is the state. And the phase 2 is same. Show crypto IPsec ASA. Phase 2 will remain same. Okay. So we can see packets getting encapsulated, decapsulated, and everything. And also we can see outbound ESP, inbound ESP SA, these things. This is clear? Okay. Any doubt? No? Okay. Now, since you haven't done the experiments, so let me do it for you. Okay. This topic is done. Okay. Right now, what we are seeing, this topic is done. Save as IKev1 policy based site to site VPN between ASA and okay, this document I'll share with you. Now see here. Right now, my communication is happening very properly, right? My tunnel is also good. So what do you think? What will happen if I go and change the ACL on one of the site? Think about it. Let's say if I change the ACL something like this, but my tunnel is already established. So my phase 1, phase 2 establishment is already done. But what is possible? Access list is there. Actually, what this access list defines, that tunnel will be created when the traffic is going for this location. As soon as you change the access list, you will lose the communication. Why? Because from site 1, let's say from the site 1 side, we are changing the access list where? On the site B. Okay. Now, what is going to happen? Your site 1 will negotiate a tunnel with this. When the traffic will be coming from your inside to the this loop back, here the access list is correct on the ASA. So ASA will try to negotiate a tunnel here. But this guy will say that, okay, my tunnel will be negotiated when the traffic is going from 10.222 to 10.333. That means we are going to lose the communication. Is that clear? Okay. So let's check that. Let me copy this. First of all, change the access list. No, access list 100. And then I'll copy this. Done. Now let's try to negotiate. Although my tunnels are already established, you can see. Show crypto IKev1 ASA. Tunnel is also gone. Okay. Show crypto IPsec ASA. No. Okay. And if I try, you will see negotiation request is going to be there. Okay. Are we able to communicate? No. Why? If you see here, my phase 1 was completed. My phase 1 is done. My quick mode is having problem. Right? So this is the problem. Okay, so if I go and check on the ASA right now, show crypto IKev1 ASA. So this is site inside R1. Okay, try again from here. Okay, and here now check. My phase 1 is active. But what about my phase 2? Phase 2 is not coming up. My phase 1 is coming up active, but phase 2 is not coming. So if phase 2 is not coming up, no data transfer at all. There will be no data transfer. This is clear. So that means when you change the access list, it's going to affect phase 1 or phase 2. It's going to affect your phase 2. Okay. And see, once the connection is dropped, phase 1 tunnel is also dropped. Okay. And if you have the correct access list, in that case, what? Check here. Once your access list is okay, complete negotiation will happen and you have to have communication. Okay. Main mode, quick mode. This is clear. Now, second scenario, what if we go and change the key? What will happen? If I go and change the key on one side, right now you can see that I have my phase 1 tunnel also up and phase 2 tunnel also up. Let's see. Show crypto ISA camp ASA. This is active. Show crypto IPsec ASA. So you can see packets getting encapsulated, decapsulated, inbound ESP, outbound ESP. We have. So phase 1 and phase 2 both are up. Now, if I go and change the key on one side, what will happen? Why? So key is mismatched, no problem. What is the phase 1 lifetime? That means 24 hours. Phase 1 default lifetime is what? 24 hours. So there will be no new negotiation until 24 hours. And in the first negotiation, already the keys are exchanged. So that means it's not going to affect your communication. Yes, after 24 hours, when there will be a new negotiation, then your communication will be affected. This is clear. Let's go and change. So, yeah, let me grab it. Let's say this time I will make it Cisco 123. Okay. Copy. See, right now, if I check show run pipe section, ISA camp. So you can see right now, what is my key? Cisco. Now let's paste it. Already exists. We have to say no for the old key. I changed, right? Okay. Let's check whether it is changed or not. Oh, let me remove the old one first. This is removed. Now this is new thing. So you can check. Do show run pipe section, ISA camp. This time key is changed. Okay. Do show crypto ISA camp. See. Any problem here? No. Do show crypto IPsec ASA. Any problem here? No. So your communication will not be affected. Even you can go and try to communicate also. You have perfect communication. Okay. See. Okay, what if your phase 2? See, phase 1 lifetime is what? 24 hours. Negotiated. Phase 2 default lifetime is 1 hour. Already negotiated. This is clear. Phase 1 is also negotiated. Phase 2 is also negotiated. Now I have changed the key. What if my phase 1 lifetime will expire now? That means after 1 hour, my phase 2 will be, what if my phase 2 lifetime is expired? My phase 2 renegotiation will happen. So it will come up or not? Why? That is in the phase 1. Phase 1 and phase 2, they have different lifetime. Phase 1 will remain up for 24 hours and phase 2 will remain up for 1 hour by default. So that means after 1 hour, phase 2 renegotiation will happen. So will my phase 2 come up or not? Phase 2 will come up or not? Because I have changed the key. Why? Okay. Let's see. This will be clear. To clear phase 2, okay, only renegotiate phase 2, we will use clear crypto ASA. Check. Show crypto ASA camp ASA. See, is it clear crypto? IPsec I forgot to mention. Clear crypto. This will clear all crypto ASAs. Okay. Let's check. Now, if there will be renegotiation for phase 1, then phase 1 will not come up. Okay. Okay. See. 1, 2, 3, 4. It's repeating which message? Those 5 messages again. Why? Authentication is not happening. Right? Here, authentication is not happening. Why? Key is changed. So if only your phase 2 renegotiation will happen, in that case, phase 2 will come up again because the keys we are configuring in the phase 1. Okay. But if phase 1 renegotiation is happening, no, it's not a loophole. It is not a loophole. How come it will be a loophole? So let's say, for example, your some important data transfer is going on. What will happen? It will drop. Correct? So that is the thing. This is clear. Okay. So now let's go back and configure correct key. Copy. Site B. Done. Now let's go and negotiate again. So now we should be able to pay because my phase 1 is and phase 2 both are negotiated. So they will come. This is clear. Any doubts? No. Now there's a task for you. Task is that you have to configure the same thing but between 2 ASAs. Between 2 ASAs you have to configure. IKev1 policy based site to site VPN between ASAs. That is your task. Okay, how you configure it? So, today's notepad I'll share. Let me close it. Don't save it. All the notes. Now I can clone. All you have to do, just instead of these two, you have to use what? ASS. Okay, that is something you have to do. So in that case, your lab will look like this is site 1 ASA. This will be site 2 ASA. Now on ASA, we cannot configure loopback interfaces. Okay, so we'll use here routers only. This one. And these are the Z0 by 0 interface on the inside. And Z0 by 1 interface on the ISP side. Okay. This IP 11.1.1.1 here, 12.1.1.2 here. And this will come here. 10.2.2.2. Here it will be 10.1.1.1. This will be your you can call it site 1 client. And this will be site 2 client. Here you can use 10.1.1.10. And this side you can use okay. And the tunnel this time will be established between the pieces. This is your task. Here. Okay. So complete this task and we'll be tomorrow. Okay. We have enough time. We will complete 1 VPN every day. Online people clear? Any doubt in today's part? No. Online people. Okay, great. So complete this. And if you face a problem, we can discuss in the group. Okay. All right. I'll see you guys tomorrow then. Have a good day. Bye bye.